review of what we've done so far. And hopefully this will capture all the things that you've learned and help you to remember what we've done, okay? When we started, we learned the candidates test when we started this unit, okay? It seemed like a long time ago, okay? And the key words for candidates test was when you were looking for absolute max and absolute min, okay? When you were looking for those two things, okay? And how did you find absolute min and max? We said you were looking for Mount Everest or you were looking for Mariana's Trench. So what you did was you took a T-chart. You put X over here, F of X over here. Inside the T-chart, do you remember you put two types of numbers? What numbers did you put in? Endpoints and critical points, okay? Then you figured out what all these numbers were, and then you just grabbed the max and you grabbed the min. Do you remember that? That was a candidates test, okay? Then after the candidates test, we did what was called the first derivatives test. And the key word for the first derivatives test were relative max, relative min, increasing or decreasing, okay? If your question asked you any of these things, then what you did was you put this into a number line. Do you remember? And instead of a candidates test, you put this into an F prime number line because it's called the first derivatives test, okay? You put in your critical points in here, and then you did plus, 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 minus, 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 plus, plus, plus. And they didn't always alternate, okay? And then you said when F prime is positive, F is increasing. When F prime is negative, F is decreasing. And when F prime is positive, F is increasing. And you could tell by the picture that you made here where you're increasing and decreasing and where your relative maxes and mins were. Okay, do you remember that? All right. And then we remember this little shorthand, okay, that helps us to actually look at graphs and understand what's happening. And that was when F prime is positive, F is increasing. When F prime is negative, F is decreasing. If you move from the top row to the bottom row, you have a relative max on F. If you move from the bottom row to the top row, you have what's called a relative min on F, okay? And this helps us to learn about our boy F, even when he's not in the room, okay? And so that was the first derivatives test. And we also talked about justification, that if you're in the same row, you are synonyms. These are synonyms of each other, and they also help you to justify each other, okay? And then the last thing we learned, I think last Thursday or Wednesday, was the concavity test, which should be called the second derivative test, but it's not. I don't know why. Okay, today we're going to learn the second derivative test, which seems like it should be called something else, but it's not. Okay, but the concavity test was basically these keywords: concave up, concave down, POIs. If you saw these keywords, you would do the concavity test. And what was the concavity test? It was just like the first derivative test, but guess what? Instead of F prime, you did F double prime, okay? Instead of critical points, you put in what was called possible POIs, okay? And instead of plugging into F prime, you plugged into F double prime. So you'd have positive, positive, negative, negative, and they didn't necessarily have to alternate. So maybe negative, negative. And what did this tell you? Well, it told you concave up, concave down, and concave down, right? This is a picture of your F. It tells you how F looks like, but it tells you the concavity of F rather than if F is increasing or decreasing. And then what we memorized for this was actually that when F double prime is positive, F prime is increasing and F is concave up. When F double prime is negative, F prime is decreasing, and F is concave down. And if you ever move between these two rows, you have what's called a POI. It's a POI on the F picture, on my boy F, okay? And if you're ever in the same row, okay, these are justifications for each other, or they're also synonyms. So if you're in the same row, you're the same. These are exactly the same things, okay? And that was a concavity test. And this is actually all we've learned except for MVT. So this was on your quiz, all right? The only additional thing we learned was mean value theorem, and that actually doesn't relate to any of those three tests. What mean value theorem says is that if your function is two things, if it's continuous on the closed interval and your function is differentiable on the open interval, okay, then you always have at least one point. You might have more, but you have at least one point where the derivative, the slope of the tangent line, is equal to the slope of the secant line. Okay, and a picture of MVT was just, you guys drew one yourself, okay, was if you had a curve and you connected 2 points on that curve, oops, okay, you connected 2 points on that curve, okay, then you ran your tangent line along your curve. And any time that your tangent line slope was the same as your secant line slope, you ran your tangent line. Anytime it was, you'd hit a C. And those C values are actually what you're actually trying to find when you set these things equal together, okay? Or your X values, we call them X, okay? Does that sound familiar? That's all we've done in this unit, okay? Actually, it's a lot that we've done in this unit. So today what we're going to do is we're going to pick it up right here at the first derivatives test. And we're going to say there's actually another way to find relative max and relative min, okay? It's kind of a special way. You use what God gave you, okay? And it's called the second derivative test. So up to this point, we only had one way to figure out relative max and min, but now we're going to have another way. And that way is this. If you have a curve, okay, and you know that you're at one of these like critical points, okay, you know that your slope is 0, okay? If your slope is 0, so let me say f prime is 0, and your second derivative is, let's see, this is concave down, right? So concave down, like a frown, concave down means my second derivative is negative. So if my second derivative is negative, then I know that I have a relative max. And look at this point. If my first derivative is 0 and my second derivative is greater than 0, right? Concave up, guess what's going to be there? That's not a relative max, a relative min, okay? And this is the second derivative test, okay? It says, go find your first derivative. If it's 0, then you might have a relative max or a min, depending on what your second derivative is. If your second derivative is less than 0, okay, use what God gave you, because this is where it's important. Less than 0, a lot of people think less than 0 means relative min, but actually less than 0 means concave down. If you use what God gave you, you could see concave down has a relative max, not a relative min. Does that make sense? This is where it's tricky. And then if you find your slope is 0 and you know you're concave up, okay, so use what God gave you. Concave up means, okay, it looks like this. Is that going to be relative min or relative max? It's a min. So it's actually kind of opposite of what you think. And that's why I encourage you to use what God gave you. Even on the test, you bring what God gave you everywhere you go anyway, right? So bring it with you, okay? And do concave up and concave down to make sure you're doing relative max and relative min correctly. Okay, so let me show you how it looks. So let's do one problem, okay? Wait, actually, let me just, before we go on, if you get a derivative that's actually not 0, so let's say my derivative is equal to -3, then what that means is it's not a relative max or a relative min. Does that make sense? Not a relative max or a relative min. Now, if my slope is 0, though, if my slope is 0, and my second derivative slope is also 0, which happens every once in a while, okay? So just FYI, it'll happen for this function here, the x cubed function, it'll happen. If both of them are 0, what that means is you don't know what's going on there, okay? You don't know. But if the derivative is not 0, then that means neither a relative max or a relative min, okay? All right, so let's go ahead and look at one of your problems. Actually, I want to go over your review problem first. So let's look at this problem here. This is really good practice to see if you understand really what's going on with your boy F. Okay, you need to take care of your boy F. Okay, he's in another room, you can't see him. But what you're given is F prime. So do you guys have this picture on your notes somewhere? Okay, so look at F prime. Remember, this is not F. This is my boy F prime. My boy F is in another room, okay? Don't call him F prime. That's an insult, okay? His name is F, okay? So here's a question. Tell me where F is increasing and decreasing. Okay, so what a lot of students do is they look at this picture and like, oh, F is decreasing here, F is increasing here, F is decreasing here, F is increasing here. You're right about the increasing and decreasing, but that's not where F is increasing and decreasing. That's where what? F prime is increasing or decreasing. Remember, F is in another room. So the only relationship you have between F and F prime is the first derivative test. When F prime is positive, guess what F is doing? Increasing. When F prime is negative, F is decreasing. If you move from the top row to the bottom row, you'll find that you have a relative max on F. If you move from the bottom row to the top row, you'll find that you have a relative min on F. So the first thing I want to know is, where is F increasing? Okay, F is increasing. It's synonymous with what? Take a look at this, guys. What's sitting right next to F is increasing? F prime is positive. Okay, if they're synonyms, that means that everywhere F prime is positive, then F is increasing. You agree? Okay, so take a look at this and tell me the intervals where F prime is positive. Okay, negative infinity to A. I'll put negative infinity first since it's smaller. Where else? B to D. Very good. And one more place? D to infinity. Very good. And some people combine this as, what would that be? B to infinity. And while it's not wrong, it's a little controversial. So I wouldn't count it wrong, but I just want to let you know, on a multiple choice test, you could have either or, okay? But this one is a little bit less controversial, okay? This one everyone agrees with. This one not everyone agrees with, because the question is, when your slope is 0, are you actually increasing or decreasing? You know, like if you had a curve like this, maybe a curve like this, okay? Right here, is my slope actually increasing or decreasing with 0? A little controversial. Some mathematicians say yes, it's increasing still. Some say no, because the slope is 0. So a little controversial there. So I would recommend just split all the intervals up. Okay. Next question. Oh, next question. Let's justify this. When F is increasing at these spots because, do you see the justification? F prime is positive. Do you guys see that? You have to justify on your test. And the justification is just wherever it sits next to. Okay, tell me, where is F decreasing? Remember, F is in another room. So very good. From A to B. Because F decreasing is the same as when F prime is what? Negative. Very good. Okay, let's go to, where do you have a relative max? All right, so where is the relative max on your F function? Well, according to this picture, what students will do wrong is they'll say there's a relative max at C. You guys see that? There is a relative max at C, but for what function? F prime. I want to know about F, and F is in another room. So the only way you know the relationship between F and F prime is that there is a relative max when F prime does what? What does F prime have to change from? Positive to negative. All right, let's be careful with this. F prime is positive on all of these values. Do you guys agree with that? All of these values, F prime is positive, right? Okay, remember, positive means above the x-axis, negative is below the y-axis, okay? Positive is not the same thing as increasing. Is everybody good with that? Okay, because right here, F prime is increasing. Do you guys see that? The F prime is not positive there. So everybody good with that? Okay, so positive are all these values. Where does F prime change from positive to negative? Which point? A. Anywhere else? No. Very good. So I would say at x equals A, and the justification will be because F prime changes from what to what? Beautiful. Positive to negative. All right. Let's go find the relative min. Okay. So we want the relative mins on F. Okay. Where does that happen? At B. Very good. At x equals B. Okay. Why are you saying at B? Because F prime changes from negative to positive. Okay. And I know you didn't write this on your paper, but I just want to say, even though when you answer me, you say it, you cannot say it when you write down a justification. Okay. You have to say, you have to name your boy. It's because F prime changes from negative to positive. You can't say because the graph changes. You can't say the function. You can't say the problem. It's got to be the boy's name, F prime. Okay, give him a name. All right. All right. Here's the next question. Where are the POIs? Where are the POIs on F? The POIs, guys, I have to use which test? The concavity test. Very good. So I'll have to go back to F double prime positive. F prime is increasing. F is concave up. F double prime negative. F prime is decreasing. F is concave down. If you move between the bottom and the top row, you have what's called a POI. And make sure you understand that's a POI on the function F. Everything in black here, guys, if you memorize it, I think, and you understand how to use it, I think you'll make 100 on your next test, okay? But the whole thing is knowing how to use this, okay? So where's the POI? The POI on F happens when F prime does what? Not changes signs, changes from increasing to decreasing or decreasing to increasing. Does that make sense? It's not where f changes from concave up to concave down. Well, it is, but this is not a picture of f, so I can't use this. And then f double prime, I can kind of use it, but not really. F double prime is not this picture, okay? So let's figure this out. I'm not using positive and negatives anymore. Positive and negatives is not the same thing as increasing and decreasing, all right? I'm trying to figure out where my POIs on f is. Guys, where does f prime change from increasing to decreasing or decreasing to increasing? Okay, very good. Do you see this point right here? Right? Decreasing, decreasing. Guys, you have to go left or right too. Okay, if you go right to left, you get the opposite answers. Just letting you know, you have to go left or right. So decreasing to increasing right here. Okay, increasing, 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 decreasing right here. Decreasing, decreasing, decreasing. Oops, right there, going back to increasing. Do you guys see that? So there are 3 points where you have POIs. Okay, they are x equals E, x equals C, and x equals D. Okay, the justification, see if this makes sense, is because f prime changes from increasing to decreasing or vice versa. You could have it go either way. Now, that was a really long justification. There's another nicer justification you can use. What could I have used instead? Very, very good. F double prime changes signs. Okay, you could have used this justification instead, which is actually a much shorter and nicer justification, but either or. Okay, and make sure you recognize both of them, because on your test, I might just put one and not the other. So you need to know both of them. Okay, and I do trick you on the test. I will put f is changing from concave up to down and vice versa. And some students will pick this this option. And I just want to point out to you guys, do you guys see how that's true? You see how it's true? It is true, but it's actually not a justification, okay? It's called a definition. That's the definition of a POI. It's not a justification. So do not pick this one. Is everybody good with that for this problem if you're justifying a POI? Okay, so we're good with the review problem. I'd like to move into second derivatives. Go ahead and skip the two review questions. I want to go straight to second derivative. So let me tell you what the second derivative test is, okay? This is what it is. I've already told you in a sense. You need to fill it out in the top. If you know f prime at some point, you're given some point. If you know f prime at that point is equal to 0, and you know the second derivative at that point is less than 0. Okay, so think about less than 0. Less than 0 means concave down. You guys good with that? When the second derivative is less than 0, that means I have a relative. Oh, I actually don't know what your paper says. Your paper says, oh, greater than 0. Sorry. Let's start out with greater than 0. Okay, greater than 0 means concave up. You guys good with this? We're on the back of your notes. Okay, and concave up means, guys, is that a relative min or a relative max? Relative min. So in your blank, you're going to put relative min, or you can put local min, okay, at x equals c. Okay, the second derivative test also says that if your first derivative is 0 and your second derivative is less than 0, okay, so remember, less than 0, concave down, is that a relative max or a relative min right there? Max. Okay, so that will be a relative max at x equals c. I need to point this out because I've pointed it out before, but I always have students mess up. If this is greater than 0, intuitively you're going to think max, but it's not. You see it's min. And if this is less than 0, intuitively you're going to think min, but it's not. It's a max. Okay, so that's why I asked you guys to use what God gave you. You take it around with you all the time. Use it. Okay, what God gave you. All right, so let's go ahead and do another problem here. And this is an example of how to use the second derivative test. Okay, so what you do first is you find all of your critical points. Actually, you find where all your slope is 0, where all your slopes are 0. Okay, and whenever we draw a picture and we have a slope of 0, there are actually, let me see, there are actually 3 possibilities. When your slope is 0, so I'm going to say this is f. Okay, do you see when you have your slope is 0, you could have what's called a horizontal tangent line here. actually these are all horizontal tangent lines. You could have a horizontal tangent line here, that's where your slope is 0, and you could have a horizontal tangent line here, right? These are all horizontal tangent lines. Is everybody good so far? But when your slope is 0, this horizontal tangent line, do you see it's called a relative min? This horizontal tangent line is called a relative max. This horizontal tangent line, is it a relative max or a relative min? Neither, okay? So when your slope is 0, you actually have 3 possibilities, okay? You could have a relative max, a relative min, or horizontal tangent line, okay? They're really all horizontal tangent lines, but this one really is nothing else but a horizontal tangent line, okay? And the way I remember that is, I was thinking about like a good rhyme for this, so that you remember when you have a slope of 0, what's going on. And it was when, remember that movie came out, Batman and Superman, Batman versus Superman, and I was really angry at that movie. Actually, that's why I made up this rhyme, because I was angry at this movie, because I felt like Superman should have won, because Batman had all these contraptions. Okay, well, actually, I just gave away the movie, so sorry about that. But anyway, so I was kind of mad about it. So I thought about, well, maybe this movie would be useful in some way. Maybe I'll make it into a rhyme. Okay, and this is the rhyme, because they're superheroes, and you know, like Superman kind of stands like this, you know, whenever like he'll stand with that American flag blowing in the back, you know. So he must be a Republican. But anyway, so I'm just joking. Okay, I actually should not make political jokes here. Okay, so Superman stands like this. And I always think of this. I always think slope of 0, superhero, relative max, relative min, horizontal tangent line. Okay, so those are the 3 times that you have slope of 0. Okay, so see if we remember it. Slope of 0, superhero, relative max, relative min, horizontal tangent line. Okay, so that's the way you can remember. We have a slope of 0. What's going on? What's going on there? Okay, so these are our 3 possibilities, and what I really want to do is find where all the slopes of 0s are. Because if I know the slope of 0, the slope is 0, and I'm concave down, I have a relative max. If I know the slope is 0, and I'm concave up, then I have a relative min. So to find the slope of 0s, what I do is I set my slope equal to 0, okay? And find all the points where that could be true. So the first derivative is equal to negative 15x4 plus 15x squared, okay? Chris, do you mind putting your phone away? Thank you. Okay, so the derivative is equal to 0. So I'm going to set this equal to 0. I'm going to go find all my critical points, okay? So what are the possibilities for this? Okay, what I'd like to do is get something times something is equal to 0. How can I find, very good, take out a 15x squared. You guys good with that? So if I take out a 15x squared, the negatives is a little tricky here, but I won't let it trick me. This is negative x squared, and this will be positive 1. You guys good with that? So all I did was I found the derivative, I set it equal to 0. I'm trying to find all the possible points where my slope could be 0. So what I have here is 15x squared is equal to 0, and negative x squared plus 1 is equal to 0. So that means x squared is equal to 0, x is equal to 0. Over here I have x squared is equal to 1. So I have actually 2 answers for x plus or minus 1. So I have actually 3 critical points here, which is kind of nice. So I'm going to find all of these 3 critical points. And I'm going to try to figure out, oh, David, it's right here on my desk. Okay, I'm going to go find all of these 3 critical points and figure out if my second derivative is less than or greater than 0. Okay, so let's figure this out. Let me just remind you, what does the second derivative test say? Okay, it says that if my first derivative, okay, is equal to 0, okay, so I already know my first derivative is equal to 0, and my second derivative is, and I don't know which one it is, but if it's greater than 0, I'm sorry, if it's greater than 0, okay, greater than 0, second derivative is greater than 0, that would be a relative min. Okay, if my first derivative is equal to 0 and my second derivative is less than 0, okay, less than 0, concave down, then I'd have a relative max. Does that make sense? I'm trying to figure out, do I have a relative max or relative min at these points? Well, so all I need to do is go find my second derivative, okay? So if I go to my second derivative, isn't that equal to the derivative of the derivative? So that would be 4 times 15, negative 60x third plus 30x. That's my second derivative. I just need to figure out, is my second derivative positive or negative? Because I already know my first derivative is 0. Okay, these are all the points. These are all the points where my first derivative is 0. So I just need to know my second derivative, concave up or concave down. So let me plug in 0. Do you see when I plug in 0, I get 0? Okay, so what that means is indeterminate. I don't know. Okay, so I would say when x equals 0, my first derivative is 0 and my second derivative is 0. Don't know. I don't know if I have a relative max or relative min there. Okay, let's try the x equals 1. Okay, so let me do it again for x equals 1. So I know that at x equals 1, my first derivative is equal to 0. I already know that because I already plugged in to find where, where is my first derivative 0? It's 0 at these 3 points. Okay, so I just need to know my second derivative, is it positive or negative? Okay, and if it's equal to 0, then I can't determine anything either. So I'm going to go find my second derivative at 1. That's going to be negative 60 times 1 plus 30 times 1, and that's going to be negative 30. Okay, do you see that that's negative? So if my first derivative is 0, okay, that means I'm either here or I'm here. And my second derivative is less than 0. Okay, think about less than 0. Is that concave up or concave down? Concave down. So what is going on right there? Relative max. So I would say, therefore, relative max at x equals 1. Okay, and just FYI, that is my justification right there. The justification is f prime of 1 is equal to 0, and f double prime of 1 is less than 0. That's my justification. You don't actually have to say you use the second derivative test, although it doesn't hurt, but you don't have to say it. Okay, let's go on and see what's happening at x equals negative 1. Okay, at x equals negative 1, I already know that if I plug in to the derivative, I get 0. How did I know that? Because I plugged in f prime is 0, and these are the 3 points where the derivative was equal to 0, where the slope was 0. So I already know negative 1 was that. I just need to figure out when I plug in to the second derivative, is it positive or negative? Okay, so let me plug into the second derivative. So here's the second derivative right here. I'm going to plug in negative 1. That's negative 60 times negative 1 times negative 1 times negative 1 is negative 1 plus 30 times this x right here is negative 1. Okay, so that's going to be 60 minus 30, which is 30. And I really didn't need to know that it was 30. I just needed to know positive or negative. So it turns out that this right here is greater than 0. Okay, so think about it. If my slope is 0 and my second derivative is greater than 0, use what God gave you, greater than 0, is it a relative max or relative min? Okay, so I'd say relative min at x equals negative 1. Okay, and my justification is right there. That is my justification. The first derivative at negative 1 is 0. The second derivative at negative 1 is greater than 0. Okay, so do you guys see how to use the second derivative test? All right. Now, this next question asks you the exact same thing, but it asks you to look at different points. So it's the exact same question, but you have to look at the points that they gave you. Let me just go backtrack, sorry. At negative 1, do you see that I graphed this function? I actually did have a relative min there. Did you guys see this? And at positive 1, I actually did have a relative max. And do you see at 0, I have neither a relative max or a relative min. It's a horizontal tangent line. But I couldn't determine it from the second derivative test. You have to just really graph it to figure it out. You can't just use the second derivative test to figure out relative max or relative min. If the second derivative is 0. Okay, so the second question really is the exact same problem, but now they're saying, hey, you don't have to find the critical points yourself, okay? We're going to give you some points to test. And this is really where second derivative test is useful. They're saying, hey, what's happening at x equals 2? And hey, what's happening at x equals negative 1? We'll give you the points to test. You don't have to go find those points, okay? So what you do is you take the derivative, which is negative 15x4 plus 15x squared. You take the first derivative, and you take the second derivative, That's negative 60x third plus 30x. And you just plug in, okay? If your first derivative is 0 and your second derivative is positive, then you know you have a relative min. If your first derivative is 0 and your second derivative is negative, then you know you have a relative max. If your first derivative is not 0, then you know you have neither. So for example, let me just draw a curve. If my first derivative is negative 3, right, that's my slope. If I said my slope was negative 3, then that's neither a relative max or a relative min, right? Because you had to have a slope of 0 to have a relative max or a relative min, okay? So let's just go ahead and plug in. So let's go for x equals 2. What would the first derivative be for x equals 2? It would be negative 15 times 2 times 2 times 2 times 2. So that's 16 plus 15 times 2 squared, that'd be 4. And whatever number that is, that's not equal to 0. Does that make sense? Right, it's not equal to 0. Okay, if it's not equal to 0, what do I know is happening at x equals 2? Is it a relative max, a relative min, or neither? So you'd say neither at x equals 2, and you're done with that problem because you didn't get a slope of 0. Okay, now let's try x equals negative 1. So now you'd say, okay, f prime at negative 1 is equal to, you go plug in negative 1 here. So I'd have negative 15 times negative 1 times negative 1 times negative 1. That's a positive 1 because that's 4 times. And then plus 15 times negative 1 squared, that's also a positive. And do you see I'd get 0 here? Okay, so second derivative test might give me something here. Let me go to the second derivative. The second derivative is negative 60. Plug in negative 1. I'll get negative 1 plus 30. Plug in negative 1. So I get 60 minus 30, which is greater than 0. Okay, so guys, if my slope is 0 and my second derivative is greater than 0, is that concave up or concave down? Concave up. Is that relative max or relative min? Okay, so then you'd say relative min at x equals negative 1. Okay, make sure you understand your justification is because the first derivative is equal to 0 and your second derivative is greater than 0. Yeah, that's what I say. Yeah, I did the same problem again. I just telling you, like, they could have written the problem this way. One problem, the second problem, they gave you points to plug in. The first problem, you had to find your points. Okay, so on your homework, you'll have both, where you have to find the points and we have to, they give you the points. Okay, and that is your answer for x equals negative 1. Okay, any questions on second derivative test? Does that make sense to you guys? Okay, so I like